Number 4, one arch of a cycloid is given by x of t is rt minus r sine t, y of t is r minus r cosine t, where t is running from 0 to 2 pi. Find the area under this arch. So what does our picture look like? So we have, this is what one arch of our cycloid is going to look like, and over here would be 2 pi, so the area in question, this is what we're trying to find here. And so for this problem, we need to use the formula for area under a parametric curve. And so that is going to be the integral, I'm just copying it straight from the textbook, the integral from t0 to t1 of y of t times x prime of t dt, where the t0 and the t1 are the bounds on t, and we can have our x of t and y of t. There's certain conditions that we have to check. Everything is checked out here in this case. So at this point then, all we have to do is plop in everything as appropriate. So our answer is going to be the integral from 0 to 2 pi of y of t, r minus r cosine of t, times x prime of t. So the derivative of this is r minus r cosine t. Oh, it actually ends up being the same as y of t. So when we distribute out this multiplication, we end up with, there's a factor of r here, there's a factor r here. I'm just going to move out those factors of r as an r squared. And we distribute out the multiplication, we end up with 1 minus 2 cosine t plus cosine squared t, all of that dt. As usual, we are going to replace cosine squared t with 1 minus cosine of 2t divided by 2. And so once you make that replacement, this is a pretty straightforward integral of 2. I'm just going to write down the final answer. It's r squared times, you end up times 2 pi minus 0 plus pi. So 3 pi r squared is this area up here.